got to figure. All right, here we go. All right, so it's going to be the oblique asymptote. So remember, it's oblique, or it's horizontal, or it's end behavior. Like you're one of those three things. You're either horizontal, or you exhibit end behavior. Down, 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 up. There are 6 options. Horizontal, end behaviors. All right, let's get started. Steps first. Is there more than one? Yeah. What do you think? And we got multiplicity is 1. Vertical, always. What's the bad value of x? What's the discontinuity with x? X equals, okay? Right? And then is y-intercept. A problem like this one, I expect that you can be specific. It's at 0, telling me positive or negative. This is nice numbers. These are nice numbers. What do you got? Plug in 0 for x, that's negative 12. So a bit of my graph, but that's all right. You're right. Guess what? Doesn't matter if my graph's 11. My graph is 22. My graph is 33. My graph is 44. Okay, that's what I'm going to do. All right, so now this is the... What is it? It all comes down to degree. Degree. So, what do I do? Yeah, Kaveen. The lead coefficients. Keep going. Okay. Lead coefficients, whatever, of the highest degree terms. Continue. Okay. Not necessarily true. So if you were to multiply out the numerator, you would have x squared, blah, blah, blah. The denominator's already multiplied out. So the lead coefficient here, you multiply, boom, boom, x squared. Agreed? Looking at the leads. This other stuff, you're right, there is. Getting there. This stuff. X minus 1. With the lead, it's x. Agreed? So far, so good? X squared over x reduces. What's x squared over x? Yes? Okay, well, now you know you need to go further. F of x, y, diagonal line. These are backwards, but whatever. So now, in the numerator, I need that whole blah, blah, blah. So I can either synthetic or, if it wasn't x, anything else but some version of x, 2x, 6x, 21x, 2/3 x, whatever, I can move on. But it's oblique, so it requires more work. Asymptote in the denominator. 1. The discontinuity in the denominator is 1, yes? So that's going to thick over long. It's just a lot easier for me. I think for most of you it is as well. And then I have to put this, this row of numbers here. What's the row of numbers? You got to multiply. Yeah, I hear a lot of rumblings. Yeah, you have to multiply it out. So I've been telling you in the past, don't multiply it out, don't multiply it out. You really don't have much choice. You cannot assume that it's at y equals x. How do you know it's not y equals x plus 3? How do you know it's not at y equals x minus 7? You don't. So we need to multiply the whole thing out, which I'm hopeful that by now you do that without having to write x squared minus 12. Squared minus x minus x squared minus x minus 12. So now 1, negative 1. Okay, great. Both times x, you guys have gotten lucky. I don't know how on earth I made it, right? And it was y equals x? Yeah, Nate? Okay, so my oblique makes it just really horizontal. I really should say oblique. Diagonal line. Okay, graph. Some of you may have already graphed. Fantastic. Your obliques, your horizontals, etc. Make sure you approach. No, it's an oblique asymptote. It's not end behavior. You're either horizontal or oblique or end behavior. Can't be all three. As Kaveen pointed out, probably didn't hear him, my graph doesn't go up all the way to 12. Unacceptable. You left unacceptable change. Is 12. Here. Okay, so just make sure you label. Percent unnecessary. 2, 4. I choose as well. Just and they are equivalent. You don't because I like to do. Okay, if you have a straight edge, you should use one. I recommend there are rulers in the back. You should get one. It's going to make So there's no look like. Going to approach where my x-intercept, not bounds. And then on, especially because of my graph, the y-intercept and the vertical asymptote away. That point, but let's do double verticals with double vertical here, not a horizontal asymptote. Here we go. You got a quiz, whenever your next quiz is next week, I think. One huge one. Okay. Wait to write it down, because I know I'm going to change my mind like 6 times. I'm going to give it to you in factored form. Makes it a little bit nicer. What happens? Like this. Oh my god. Yeah, P over Q. P over Q. But lucky for you, I'm going to give it to you factored. Okay, but hold off, because mine 6 times. Sorry. But enough where you can, like, that is it. 4, 7, 10. 10's too big, 1's too small. No. Let's do. Oh, okay. And you are good. Your highlighter zoomed 5 minutes. Do you have it written down? Okay. I've been doing this a long time. I figured out yesterday that I've been teaching Algebra 2 honors longer than you've been alive. This is year 14 for me. So if you're 13, 14, some of you are 15, like, that's a long time, right? You agree it's a long time? So I kind of sort of know what I'm doing? Yeah? Okay, so I know where all the mistakes come. So I'm going to warn you. Okay? We good? Factor first. Always, there's no exception to the rule, factor first. I gave it to you factored form. So that was nice. Yeah, that was nice of me? Yes, okay. Then you're going to reduce. And when you reduce, you need to be very careful about what it looks like after that happens. All right, let me use a different color here. Let's use red. Okay. Awesome. If it's not factored, how do you reduce? Right? I mean, you might want to do that other word instead, but you still can't do it unless you factor and reduce. You cannot do that other thing if you don't factor first. Okay. Reduce it. I want you to reduce it. Go for it. This is what you tell me, what's left? What's it look like? Tell me what's left. 2. Component from the numerator to the denominator. You should know by now to use pencil in my class. You should do all of your math in pencil. There are erasers in the back. There are pencils in the back. There are rulers in the back. Like, I don't know what else I can possibly give you, realistically, for a math class. All right. What I think happens is the factor x plus 6 moves from the numerator to the denominator. Is that what happens? Okay, great. That was my goal. For me, I got a whiteboard. I just go, psh. What I need is a eraser. 3x minus 7? You with me? So here's what happens. Everybody thinks we have all. Do you agree? Okay. There are bad values. I call them bad values. There are issues with x. If x is 3, if x is negative 6, and if x is negative 2. Agreed? Sort of. Oh, I need to close those parentheses. I took out the positive 3. Yes? So now x can be 3? Now it can. Well, sure. Can x be 3? Sort of. I didn't take out negative 6, really, because if x is negative 6, 0 in the denominator, If x is negative 2, 0 in the denominator, bad, yes? Okay, so what we're going to do is we're going to just off to the side, we're going to write down our discontinuities that we removed. So we reduced we took out x equals 3. It's still here, but we did take it out. Yes? Agreed? It was a 4. Get rid of part of it. We removed part of it. And then we removed partly a negative 6. Would you agree with that statement? And we removed negative 3, 6. What else did we reduce? That's it? Okay. All right. So you'd say, oh, those are removable discontinuities, et cetera, et cetera, et cetera. Okay. But there are still problems. The issue of negative 2 is still there. So what do you call x equals negative 2? A vertical asymptote. If x is negative 2, no. So we have a vertical asymptote at x rotation. So far, so good? Okay. We took out. Agreed? That was bad initially. X equals 3 was bad, but now x can be 3 because we took it out. right? That's a hole. Plug in 3. Do you get 0 in the denominator? Great. What do you get when you plug in 3? What do you get when you plug in 3? This is okay. You get 0. When you plug in 3, you get 0. Yeah? 0 over 12 or whatever it is. So 0 over 12 is 0. Agreed? So that's an x-intercept. Numerator is 0. It's an x-intercept. Nope. It's a hole. It's a hole. The x-axis. It's a hole on the x-axis. Yeah? I'm not done. One thing at a time. There is another one. Okay. Negative 6. When you substitute back in the negative 6, where do you get the 0? And the denominator, never, ever, ever. It's not a hole. It's not an intercept. Well, asymptote at x equals negative 6. And there you go, Victoria. There's your other asymptote. By the way, do not write this. Don't be lazy. Okay, we've got vertical asymptotes. We've got holes. Let's find x-intercepts. You did it right there, didn't you? In the problem in that's like nice burgundy color. Reduce, and then look at your holes. Take care of the x things first. So we're taking care of the x things. Vertical asymptote, the hole, whatever. X numerator. The x-intercepts come from the numerator. Okay, so if you set the numerator equal to 0, you get, let me write off to the side. So you get 2 equals 0. 3, 0 with a multiplicity of 3. Yes, hold that thought. And then 7/3, multiplicity of 1. What'd you say? It's a hole. You cannot be an x-intercept and be a hole. Intercept. So we have 7/3 with a multiplicity. Crosses. By the way, you can bounce and cross off holes. Multiplicity is 3. So we're going to cross over the hole, sort of. It's in the denominator. Never. Ever. There's a couple ways you can be a hole, Nate. You can be a hole if you have x plus 4 to the 5th over x plus 4 squared. When you reduce that, you get x plus 4 cubed. That's a hole on. If it reduces out completely, like x plus 4 to the 5th over x plus 4 to the 5th. So this is a hole on the x-axis. This is just a flat-out hole at -4 something. So it's like I partially removed the discontinuity, but it's partially still there. If you're not sure, always plug that value back in. Plug in -4, there'll be some more of a equation, and we would check it. So let me finish this one, and then we'll do Y-intercept. That should hopefully be the easiest part. Y-intercept. Like, when is it okay for me to say it's actually find it? I think we can find this. What do you mean 54 times 7? Oh yeah, negative 27 times negative 7. How much is that? This is negative 27 times 2 times negative 7 over 12. 2 times negative 27 times negative 7 over 12. So this is over 6. It's positive 9. Carry the 4. Negative 329. Is that right? Is that right? 9. No, that's not right. 14 plus 4 is, how about 18? How about 189? What? How about you do the problem with me instead of staring at me, waiting for me to figure it out? 27 times 7, I believe, is 7 times 7 is 49. Carry the 4. 189. Which divides by 3. Divide by 3 and you get negative 63 over 2. Because it's reducible. You can reduce. This is a fraction that you can reduce. The trick, add the digits. 1 plus 8 plus 9 is 18. 18 divides by 3, therefore 189 divides by 3. What, Nate? I divided to find the y-intercept. I plugged in 0, negative, so that's negative 3 cubed, which is negative 27. The 2, negative 7. If x is 0, you get 12. Yes, Sarang. Yes, positive 189. Thank you. Yes, yes, yes. All right, 63 halves. 31 something. Yeah, that's too big. I'm just going to say it's positive. I'm not going to graph 30 point something. You need to find, say it's positive or negative. I made a... So after all that, the end bit. Reduced to figure out oblique, end behavior, horizontal. There's pros and cons to both. This could technically be a pretty high degree. What if you made a mistake reducing? What's the degree of the numerator? What's the degree of the denominator? What do you get? Figure it out. Degree of the numerator. Property of the exponent thing.
Like the x to the n over x.
How about the division property? Oh, what just happened? Hello? Oh, man. Nope. Asymptote. Which means it must fall into the end behavior category. What? Okay. The degree of the numerator. Four, 5, 6. It's 4, 5. 5, 6. Of the original, what's the degree of the denominator? 4? Okay, so if you'd have blah, blah, x to the 6th over blah, blah, x to the 4th. Agreed? Okay, the reduced equation. 3, 4 over 2. You still get 2 either way. Okay? You still get 2 either way. Whether you look at the reduced or the original. So y equals x squared. When you're all done reducing, it's something, 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 blah, blah, blah. Y equals x squared. Blah, blah, blah. I don't care about the blah, 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 blah. That's a parabola. So this is a parabola. So it is overall, the degree is even. A is greater than 0. So this is end behavior. Up, up. Now we're going to graph this whole thing. We know. And then we'll go from there. Plot the blah, blah. That's my favorite math word today. Blah, blah. That sounds like a spit it out memorization to me. I look at the degrees and go from there. If you're left with the degree y equals x is a diagonal line, it's oblique. If it's y equals negative 3, that's a horizontal line, it's a horizontal asymptote. And if you're left with y equals x squared, x cubed, x to the 4th, we don't graph those kind of asymptotes, we graph end behavior. Just look at reducing it. I always just look at reducing it. Yeah, Michelle? Wait. Isn't there a case where what? Yeah? Yeah, y equals 0. What happens is x gets infinitely large. So you have something, whatever. You end up with 1 over x. You end up with 6 over x. Negative 10 over x. As x gets really, really large, what's the fraction approaching? Okay, the goal is uh, 3, 0 as a whole. 7/3. What did we say the y-intercept was? Positive? Great. What else? 7/3, 3, 0. Y-intercept. I think for the end behavior. I've graphed everything except for the end behavior. I'm not going to plug in a single point. It's from the furthest intercept. It's from the furthest point to this is the correct? Everything crosses. So I'm going to, don't draw it over, so to speak, the whole. cross over 7/3. And I'm going to come like a V. It's not a V. Okay. I didn't draw. Oh, right. Are there any more steps for this? Has end behavior. There are two options. Are there any more x-intercepts on this graph? None. There are no down, because if I exhibit, agreed? Single point. If it goes x-axis, no can do. Agreed? Which means it either goes down, down, or how am I going to figure that out without the bell's going to ring? All right, we're going to continue this tomorrow. If you want your quiz back, I have that. Grades are in Aries already. But if you want your quiz, you still need to do the homework. Ugh.